Which of these formulas represents an alkene? An alkene is a hydrocarbon that contains a double bond in its carbon backbone. We have three formulas to consider: C3H8, C3H7, C3H6. These are all propenes because of the number of carbons gives us the prop prefix. Let's start with a picture of a propene saturated with hydrogens, and then we'll do the formula as the second part as a double check. Because these are all three carbons, let's start with three carbons right there. And we're told that it's an alkene, so we have to have a double bond here. We can put the double bond here or here. I'm going to choose to put it here. Now, carbon likes to bond 4 times. Please put that to memory or in notes, because it's it was an early thing I learned that helped prevent mistakes down the line. This carbon on the left here is only bond uno, so it can take on 3 more hydrogens. This bond in the center here, this carbon in the center here is bonded, so it can only take on 1 more hydrogen. And this terminal carbon over here can only take on 2 more hydrogens, excuse me. So this is a propene, and it is C3H6. So this is our formula that represents an alkene. We can prove this with a little, and let's look at this picture here compared to a molecular model to kind of note how inaccurate but accurate it is. It's accurate in the number of carbons and hydrogens, but very inaccurate in the geometry and the kinetic nature. This static 2-dimensional image doesn't show the 3-dimensional character of it. Notice that that central carbon puts a bent character to the entire molecule, making it look like a letter V, if you will. Note how the pi bond on this side, there's restricted motion around that pi bond, and the methyl group on the end here has free rotation happening there. We can also confirm that this is a generic formula for an alkene using this little formula for alkenes. Oops, should be an N. We can calculate the number of hydrogens based on the number of carbons. So this is C3, and that is 2 times 3 equals 6. So C3H6. That's a double check. Hope this helps. Thank you.